Hello everyone and welcome to lesson 15. We're very glad that you could join us today. The first item on our agenda for today is our project talk. Last week we went through with you guys who all your team members are, and we've put them up here as you guys told us they were. We would obviously like you to work together in teams because it helps you learn from each other and do things together. So please review this list if you haven't seen it already, and please let us know if there are any changes that need to be made. We'd also like to announce this week that we are going to start allocating the last 30 minutes of each lesson. So that is going to be today's lesson all the way up to lesson 18 towards project work. So you'll be able to work on your project in class and ask us any questions you might have regarding things you're trying to do in your projects. We will also be allocating the whole of lesson 19, so the second last lesson, to the project. So you'll get an hour and a half there to work on your project, and lesson 20 will obviously be the presentation of your project and our scoring and awarding of prizes. Last time we did a few things. We focused mainly on string manipulation. Remember, as you can see at the bottom of the slide here, a string is a list of characters. Okay, so this is a string, is actually a collection of individual characters, THIS and space, IS space A space STRING exclamation point. Remember, even the characters you can't see, like the space, are still part of your string. And we discovered how to manipulate strings using the length of string and character at position in string blocks. We used these in the examples where we counted the number of vowels in a string, fixed the spelling in strings that were provided to us, and an exercise where you spelt your own name. We also did an exercise at the end of last lesson which explained how to encrypt and decrypt user-entered text. Now, for some of you, encryption and decryption was a new concept. Encryption and decryption basically means taking input text and converting it into something else which doesn't look like the input text. So you can send that to a friend and they can then decrypt it and turn it back into the original text and see what the message was that you were trying to send them. So what we have is we have a substitution cipher. So we have all our letters of the alphabet. We haven't included space and punctuation here to keep it simple. And then we have a substitute for those letters. So A will go to Q, B will go to W, C will go to E when we are encrypting. So in our example, G goes to U, R goes to K, A goes to Q, and Y goes to N, and so on for the rest of the sentence. When your friend then receives the encrypted version, which obviously doesn't make any sense because it's not English, he or she would then do the reverse procedure. So they would take the letters that you've got here, look them up in our list over here, and convert them back to what they should be. So if we go and look for U, where's U? There's U. U should become G. If we go look for K, there's K. K should become R. If we go look for Q, there is Q. Q becomes A. And if we look for N, N becomes Y. And that gives us our grey back. Just on another point, grey is one of those English words which can be spelt in two ways. It can be G-R-A-Y or G-R-E-Y. Another example of that is disc. Disc can be spelled D-I-S-K or D-I-S-C. We didn't get to finish this example, so we might come back to it in a future lesson. So hopefully you guys can learn how to do encryption and decryption properly, which is quite an important thing when it comes to programming computers. Okay, today's mission is we're going to explore the repeat until, which you can see over here, and the forever block. Okay, which is two other kinds of loops together with the repeat number or repeat count block, which we use quite often. We've also used the forever block in previous exercises, but we haven't gone into a deep explanation of how it works. We are going to do 2 or 3 examples today: the times table machine, which you are going to do from scratch, the addition test, which you are also going to do from scratch, and then we're going to learn how to stop a script and load a script that's already on your flash drive to explore how that works. Alright, let's get back to our blocks. We've got 3 loop blocks. We've got the repeat count block, the repeat until block, and the forever block. Now these blocks have some other names which we can also call them by. The repeat count block is also called a counter-controlled or definite loop. Counter-controlled because we put in a number here which says how many times this loop must happen. So we call this value here, 10 in this example, the counter. So when we reach this block, we definitely know how many times it's going to execute or run or loop, because we tell it how many times using the counter. So this repeat count block is also called a counter controlled block because we use a counter, or definite loop because we definitely know how many times it's going to loop. The new block that we are looking at today is called the repeat until block, and you'll see excuse me, the block here after the until is a hexagonal shape. And as we've learned in previous lessons, hexagonal shape blocks give us a Boolean output or a Boolean return value. And Booleans only have 2 values. It's either true or false, yes, no, 1, 0. There's only 2 values. So this loop will repeat until the output of this conditional block becomes true. If it doesn't become true, then it's going to carry on repeating forever. So this hexagonal block here is called a condition. So that is why this loop is called a conditional controlled block or an indefinite block. And it's indefinite because we don't know how many times it's going to loop, because it all depends on when the condition becomes true here. Unlike a repeat count block, which is a definite loop, because we tell it from the get-go how many times to loop. The last block we're going to look at, which you've seen before, is the forever block. And you can see this doesn't have any inputs or parameters. It just says forever. And this is also called an infinite loop. It means a loop that carries on running for as long as your program is running. Now it's very important with infinite loops to make sure that that's what you want it to do, because it could very easily happen that you set up a forever block and your code executes, but other code that you also want to execute never gets a chance to execute. So we'll see just now a way of using a forever loop, but in such a way that gives you more control than running everything inside the forever block forever and ever. This picture on the right hand side is a picture of a thing called a Mobius strip. It is simply a piece of paper that has been twisted or half twisted once and the ends glued back together. It has a very unique property in that by twisting or half twisting the paper and gluing it together, we land up with a loop which actually only has one side, and it also only has one edge. So if you make one of these at home, and we'll include a YouTube video on our supplementary materials page, we will show how you can color in the paper, and you'll only be able to color it in with one color, because although it seems like it has 2 sides, it actually only has one. The same holds if you were to try and draw a line on only one side of the piece of paper. You would draw and draw and draw and draw, and without lifting your pen up, you would eventually come back to having the same starting point of your line. I know it sounds a bit confusing, so be sure to watch the videos to see how it happens. Okay, the exercise that we are doing today is called our times table exercise, okay, and it uses a definite loop. If you remember, definite loops include a counter, so we definitely know how many times this loop is going to run. So let's read what the description is of what we have to do. We have to write a program which asks you for the times table you want to practice. Example, enter 3 for the 3 times table. So to do this, we are going to have to use the ask and wait block to get from the user the times table that they want to practice. The second step says the program then says the times table you choose. For example, the 3 times table from 1 to 12 in the following form. So we are going to use the say block, and we are going to use the join block to construct our string of text, which says 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and so on. Okay, so this is not a very complicated program. The most complicated part of it will most probably be the join block, which we'll go through. I think there's 6 lines in total. So let's switch over to our Scratch editor and start doing this program. So as always, we start off with the when green block clicked, or the green flag clicked, and then we need to ask the user which times table they want to do. Okay, double clicking on the text selects a word, okay, and if nothing is selected and you double click on it, it selects everything, which is an easy way to type over the default values. So we are going to say, which times table would you like to practice? Question mark. Alright, and now we are going to use our repeat with the count block, okay, and we are going to repeat 12 times. Okay, and then we are going to use our say block. There we go. And we're not going to keep it at the default 2 seconds because that might be a bit too slow, because 12 times 2 is 24. So let's change it to 1.5 seconds. And then we have to put in, using some of our join blocks, the 1 times 3 or 4 or 5 equals 3, 4, or 5, etc. Now, the one thing we need to note here is that although we know we are going to repeat it 12 times, and we know which times table we are going to use, because we'll have that from the answer block, which goes together with our ask and wait block, we need to know which step we are on. So we are going to create a variable called count, okay, and we're going to put that in over there, and we're going to start it off at 0, and then for every time the loop runs, we are going to change count by 1. And this count variable is going to be the counter for our times table. So it'll be the 1 in 1 times 3, the 2 in 2 times 3, the 3 in 3 times 3. And you'll see how that fits together now when we do our joins. So let's do our joins, okay? First of all, we need to know what our answer is going to be. So we are going to use multiplication, and we are going to say count, which remember is your 1, 2, 3, 4, 5 all the way up to 12, and your answer, which is the times table that the person asked for. Then we need to build up our string, which says 1 times 3, for example, equals 3. So we're going to need a couple of join blocks, so we'll duplicate them. Saves us dragging them off the palette every time. Okay, and remember, join block can only take 2 values. So we can say 1, which isn't going to help us because it's not always going to be 1. So we're going to say count, and then we're going to say times, and then we're going to use another join block, and we're going to say answer. Okay, and then we're going to put this join inside where it says hello here. So we now have count times answer, and then we need another one which says equals, and we're going to put that join inside there. And now we need to say what the answer is. Well, we know what the answer is. It's this value here. So we need to join those two up. So here we've got another join block, and we're going to put this in the left side, and we're going to put that in the right side. Remember, when I move the blocks over, when it's ready to accept something, you'll see there's a little white border that comes up around the block. When I move this over, there's the white border, so we know we can drop it and it'll plug right in. Now we take this and we plug it into our say, and there we go, there's our program. So if we run it, which times table would you like to practice? Let's practice the 3 times table. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. But as you can see, that didn't look too nice and neat. So let's go and add some spaces in to space things out nicely. And what you'll see is I'm putting spaces before and after the multiplication sign and before and after the equal sign. So if we do that again, you see now we've got some spaces and it's easier to read. If it's going too slow for you, we can drop this and we can say half a second and see how quickly that goes. There you go. See, it's going a lot faster. Now, although in school you most probably only do up to the 12 times table, because you have now written a program, you can do any times table you like. So if you wanted to do the 24 times table, easy as just entering the number. If you wanted to do the 615th times table, there you go. Easy as pie. So now you can see why we use computers to do complicated mathematical exercises, because it's very easy for them to do them. Alright, so let's go back to our slides. So we managed to complete this exercise. Alright, and that's what it looked like, more or less. You might see that the joins are not in the same order always. It doesn't always matter that the joins are in the same order, as long as you have grouped them together in a logical fashion. And we'll be doing a video a bit later to show you how to do that, and hopefully help you understand how the join block works a bit better. Alright, condition controlled or indefinite loops. These are the loops which are new to you today, which have a test condition in them. So it says repeat until test condition equals true. So when we start this repeat until block, the test condition is checked, and every time the loop runs, the test condition is checked. When the test condition is true, then we carry on with the next command underneath here. So if we have a look at our flow chart, we come in at the top, we have a test condition. If it's false, then we execute the commands in the body of the loop. So command 1, 2, all the way up to n. And then we come back to the top and we test the condition. If it's still false, we carry on in the loop, but if it's true, then we come out of the loop and we go to the next command. So you can see it here in the drawing. If your condition is false, it runs through the loop and goes up to the top. If the condition is true, it skips over the inside of the loop and goes straight to your next command. Now it's important to note that if your test condition is true when you come in for the first time, the commands inside your loop will never be executed. Okay? And in the same way, if your test condition is never set to true, then, so it is always false, then this will become an infinite loop, because it won't be able to escape out of the loop. Usually what you do is inside your loop, you change the value of the test condition to make sure that you can exit the loop. And that'll become clear in the exercises that we're going to do. So exercise number 2 is we're going to do an addition test. Okay, using the indefinite loop, which we've just discussed. So, what we need to do is we need to pick 2 random numbers between 1 and 50 and then ask what their sum is. So for example, 34 plus 56 equals, and then the user has to supply the answer. Now for you clever ones out there who are watching the video, you'll notice that I didn't put the right value in here because I put a value in greater than 50. So technically this number and this number, neither of them should ever be more than 50 according to our instructions here. You then need to enter the answers for the sum. If you're right, the program must end. So we must set the true condition for our conditional loop to true. If you're wrong, the program must ask you for the answer to another sum. In other words, go back to step 1 here, pick two new random numbers and ask what the sum is. Okay, this builds on what we did in exercise 1, and again, one of the most complicated parts will be the join command. So let's go through to our Scratch editor, start a new program. Alright, and as usual, we start with when green flag clicked, and then we need to create a variable which is going to be used in our condition for our repeat until. So let's call it past test. Okay, now the variables in Scratch allow you to put spaces in them, but in general it's not a good idea to do that, especially in other programming languages which won't allow you to put a space in. Also, another point to note is we could have named the variable like this. Okay, it reads the same, but it's more difficult to read because we've put two words together. So what we usually do is we capitalize the letter of each word that's in the variable name, and this is called camel case, and it makes it easier to read the variable. Okay, so the first thing we're going to do is set our pass test to false, because we haven't asked a question yet, so the user can't have chosen the right answer. Then we're going to use our new block, the repeat until block. Okay, and then we are going to put a condition in there, and for a condition we are going to use our operators, and we are going to say if our pass test variable is equal to true, okay, then we must exit the loop. Okay, but because we're starting off setting it to false, pass test will not be equal to true, so we will execute the loop at least one times. We're going to need two more variables. We're going to call them number 1 and number 2, and that is where we are going to store our two random numbers which we're going to add together. And we need to set those variables, and let's start off with number 1, and we're going to use our pick random block, and the value must be between 1 and 50. And now let's do the same for number 2. Okay, change it to number 2. So now we've got our two variables. Now we need to ask the user what they think the answer is. So we are going to use our join operators again. Okay, we need a couple of them, so let's duplicate them. Okay, so there we have our duplicates, and now we're going to need our variables. So we are going to say number 1 plus, remember to put your spaces in to make it look nice. Okay, and then we're going to say number 2. Okay, where's our variable number 2? Over there, and then we put that inside there. Now we have number 1 plus number 2, and we are going to say equals, whoops, with our spaces, and we are going to say equals question mark, because we are asking the user what the answer is to that. And then we go put that in there. Okay, and we don't need that one. And now the user types in the answer to the sum. Now we need to go and check if they have supplied the correct answer. The best way to check is using an if then, and then we need to use our operators once more. We need to use our equals operator, because remember this is a hexagon and that goes inside there. And we need to find out what the answer is as well, so we need our plus. And we are going to say number 1 plus number 2, is that equal to the answer that the user gave? And we'll put that in there. Alright, if it is, then we have to set our variable which lets us exit the loop. We have to set it to true. So there we go. And that is our program. So if you run it now, you can see pass test equals false, Number 1 is 16. Number 2 is 45. 16 plus 45, I think that's maybe 50. Oops, it's not 50. 29 plus 1, that must be 12, I'm sure. Oh, that's also wrong. So you can see every time we put in the wrong answer, it asks us another question. If we put in the right answer, 22 plus 50 is 72, then you see the program stops. And if we really wanted to, we could put in a little message saying, well done. Well done. You got the answer right. And if we run our program now, okay, it still carries the same. 10 plus 3 is 13. Well done, you got the answer right. So there we go. Pretty simple program, which illustrates the conditional loop here. Okay, next exercise. So that's what we landed up with. Okay, obviously we added on an extra block at the bottom here to tell the user that they got the answer right. Okay, our last loop, which we have covered already, is the infinite loop, also known as the forever loop. And as you can see, it doesn't have any parameters or inputs after the word forever. However, this isn't always that useful. Okay, we would like to not always run everything inside the forever loop. So to do that, we put in an if-then block with a test condition. Only if the test condition is true will the commands inside the if-then block be executed. This is called turning an unconditional infinite loop, unconditional because it doesn't have any condition here, into a conditional infinite loop. So it still runs forever, but the code here only runs if this test condition is true. So if the test condition is false, then we go back to the forever loop. If the test condition is true, then we run through these blocks and then go back to the forever loop. You should notice that at the bottom of a forever loop there's no bump. No bump like this or this or this, which means we can't put anything underneath or at the bottom of a forever loop. Okay, we've used forever loops before to move things around on the screen using the keyboard. We usually use the if key pressed hat block. So a block looks like the green flag one, but you get to choose which keyboard key to check for. In this case, we've used a different key or different way of checking the keyboard key. We've used the blue key right arrow pressed, or left arrow, or up arrow, or down arrow. This blue block is very useful for checking different things. So if we go and have a look here, go to our sensing palette and we go and find our block here. See, you can choose all sorts of things. Now this is more useful because it allows you to check for more than one key in the same script. So as you can see here, we can check for the right arrow, left arrow, up arrow, and down arrow. Whereas when we used the hat block, you had to create a whole script for each key that you wanted to check. Okay, so stop commands. Stop commands are obviously used to stop your scripts or your program from running. There are 3 stop commands. The first one is called a stop this script command. Second one is stop all. And the third one is stop other scripts in the sprite. Now it all comes from the same stop block. So if we go have a look under our control, we go and find our stop block. You'll see it defaults to all. We can also go this script, and we can also go other scripts in the sprite. Now, the difference between these two is, remember, a sprite can have one or more scripts, and your program can have one or more sprites. So, if you put this block inside your script in your sprite, then it will stop that script in your sprite. Scripts in other sprites will carry on running, and other scripts in your sprite which don't have this in will carry on running. The stop all will stop all scripts in all sprites, so it'll effectively stop your whole program. And then the stop other scripts in sprites will stop scripts in the current sprite that are not this script. Okay, I know that sounds a bit complicated, and we'll have a look in our example here in a minute. The other important thing to notice is these three blocks differ in one other way. The first two don't have a bump underneath them. When you don't have a bump underneath, it means you can't add more blocks below that block. So if you call this stop this script or stop all, you can't call any blocks beneath it. If you call the stop other scripts in Sprite, then you can have other blocks underneath the script. So let's go and load up the stopdemo.sp2 from your sessions 13 and 14 folder on your flash drive. Okay. This script consists of 3 sprites. Okay, we have 2 balls, a red one and a green one, and we have our witch. Okay, we are going to control the witch, so you can see in her code when the green flag is clicked, she goes to the middle of the stage, she points in direction 45, which is in that direction, and then we have a forever loop, and it checks our keys that we are pressing. And we are using the blue key press block, which we just went over, and we use that to move the witch around the screen. Okay, on the green ball, okay, we have it go to x200 and y minus 100. So x200 will be up at the top here, and y minus 100 will be to the left. Then we have a forever loop, and the ball points towards the player and then moves a random value between 0.5 and 3, and then if on edge it bounces. If it's touching the player, then it changes the speed, which is a global variable, which you can see here or over here, and then it stops the script. So if the green ball touches the player, then it increases the speed, it makes things go faster, and it stops the script. So then the green ball will stop moving. On the red ball, it also starts at minus 200 on the x, which is to the left, and y 100, which is up here. It sets the speed to 3. Okay, and then we have a forever loop, and we point towards the player like the other ball, and we move speed steps. So you see the red ball can go faster, whereas the green ball moves at random speeds between half and 3. Whereas the red ball goes at the speed variable steps, and if it's on edge it bounces. If it's touching the player, then it will play a sound, and then it will stop all. So when the red ball touches the player, everything stops. When the green ball touches, only the green ball stops. Okay, so let's have a look at this in action. Let's make it a bit bigger, and let's get going. And we have to dodge the balls. Okay, you see the red ball touched the witch, so the whole program stopped. Okay, if we start that again, we touch the green ball, see the green ball stop, but the red ball carried on going. Let's try that again. Green ball stops, red ball goes until it touches the witch. But watch, the red ball goes faster now. Okay, this is a bit of a tricky game. Oh, there we go. But you get the idea. The green ball stops when it touches the witch, and it makes the red ball go faster. One more time. There we go. Alright, I think you get the hang of that. Right. So your homework, okay, because in the second half of the course, your homework is to work on your project. Please also check out our website for lesson 14, which is last week's lesson, and lesson 15, which will be available from Monday. Alright, next week we are going to talk about validating user input. It's one thing to ask your user to type in a value, but you have to check that they put in the right value. If you tell them to enter a value from 1 to 50 and they put in 600, it might cause a problem for your program. So the lesson is, don't trust what the user says, check what they put in is the correct thing. We're also going to cover using counters in loops. We've already been over that a little bit in our multiplication problem today, but we'll go into it in more detail next week. And then, as usual, please shut down your computer and don't forget your flash drives. Thank you very much for coming, and we hope to see you at the next lesson.